Alright, so I know Saranya will not be able to join and other kids are yet to join. So before we get started, just a quick question to you all. Whatever we did yesterday in the class, is that clear to everybody or there's something open-ended yet? So just to help you guys recall, we talked about what is standard deviation and then we were trying to solve one of the problems, one of the word problems relating to the data analysis and problem solving basically. Hello, Jasmita.
Hi, sir.
So my question to you all is, whatever we did or talked about with respect to standard deviation, is that part clear? Okay. So in today's class, what we'll do is, we'll try breaking our head with few more word problems relating to problem solving and data analysis. And again, as I mentioned, that we all know what is mean, median, and mode, what is center spread, calculation wise. But when it comes to problems related to that, it is not going to come as easy as, okay, find out the mean of these numbers or find out the mode of these numbers, right? There will be a little more spice into it and we will have to decode the message or the information that we have within the class and then try solving it. Okay? So that's the main reason why I wanted to kind of share some of the legitimate problems that you guys will come across and then we'll see how do we go about solving them. Yeah? Alright, Anil.
Hi.
Now a quick question for you guys. Can you guys see my finger moving on the board? The full board is visible? Wonderful. That was a quick check. Now we need to get started with what we want to do today. Okay. So can you guys see the cleanup happening on the board? And if yes, that means the board is visible to you all. Okay. So let's look at some interesting problems and then we'll see how as a group we are able to solve them or address those questions. What I will do is, I will draw a picture with my limited drawing skills and we will see what this question says all about. This side it is acceleration, and I'm assuming that you guys know what is acceleration, right? I mean, you press the gas pedal, car starts moving faster, you are accelerating the car. You press the back brake, car starts moving slowly, that's called deceleration. So when you're going at a certain speed and when you press the accelerator, you are increasing the speed. That is what is acceleration. And we're not going to talk about the physics behind. Just wanted to make sure that when we talk about acceleration, at least you guys are not thinking too much about what exactly is happening. So on this axis, we have acceleration given in meter per second square, and this axis we have time. Okay, and then we have a graph which starts from here and goes all the way till 200 and comes down and hits here. And at 15, this is the peak. Okay, so this is all about the drawing that we have in the question. And let me read the question now for you guys, and we will see what exactly is asking us to. Everybody can hear me okay, right? Riya, Yasmita, Neil, Jenna, Praneet, Vivan, Samriddhi, everybody? Vishwa? Okay. Now hear me read the question for you. The graph in the T and A plane. So this is T, and this is A. Short form of acceleration, and T the short form of time. The graph in the T and A plane shows the horizontal acceleration A in meter per second square, okay, of an elastic ball thrown against a wall T milliseconds after it impacts the wall. What is the significance of the graph at T equal to 15 meter per second square? Let me read that for you guys one more time. This is a graph. Here you have acceleration, here you have time. The question says the graph in the T and A plane, like we say XY plane, right? So here x-axis is nothing but my T and y-axis is nothing but equal to A. So the graph in the TA plane shows the horizontal acceleration A in meter per second square of an elastic ball. Look it up. So I see some kids have joined after I started talking. So I see Ritika is here, Sara is here, Vishal is here, and yeah, Vishwa was there before also. So, alright, so welcome everybody. We just started, just to set the context for you all who joined a little late, is that we were talking about data analysis and problem solving, and we talked about standard deviation, some of the commonly used tools, Yarosh, like line graph, bar graph, histogram, right? These are the things that we talked about. So, in today's class, we are going to look at some of the problems, right? I mean, you guys know about how to calculate mean, median, mode, how to read a bar graph, histogram, and things like that we talked about. But now we are looking at some of the actual problems that you guys will deal with, and we'll see how do we wrap our head around that. Yeah? Is everybody okay? Ritika okay? Yeah? Okay. I just called out one name. That doesn't mean everybody else can afford to be not okay. I'm assuming everybody is okay with one name being called out. Alright? So, this is the graph that we have. We are looking at one of the first question that we want to solve as a graph. This is the graph. Here on this y-axis we have acceleration in meter per second square, and on this axis we have time. The question says the graph in the T and A plane, this is T and this is A, T and A plane, shows the horizontal acceleration A in meter per second square of an elastic ball thrown against a wall T milliseconds after it impacts the wall. So it is talking about what will be the acceleration after T milliseconds after it hits the ball. So when the ball hits the wall, there is no acceleration. After it hits the ball, this is representing that how the acceleration is changing. After 5 seconds, maybe there was some acceleration. After 10 seconds, there was some acceleration. After 15 seconds, there was some acceleration. After 20 seconds, there is some amount of value of acceleration. Okay. So this question says, what is the significance of the graph at t equal to 15? At t equal to 15. And here are the options that we have. The elastic ball touches the wall for 30 milliseconds. That is the first option. Second one says the elastic ball reaches its greatest horizontal speed 50 milliseconds after the impact. The elastic ball experiences the greatest horizontal acceleration 15 milliseconds after the impact. That is option C. And the option D is the elastic ball experiences the lowest acceleration after 15 milliseconds. So forget about all the options. Just by reading the graph, what is the interpretation of when t is 15? Ignore the options. Yes, Jenna.
Can you repeat the options again, please?
Okay, so let me be a little what do you call? Little strict teacher here, okay? So don't get me wrong, okay? I'm saying This is the graph given to us. Okay. Options might confuse us, but I'm saying when you see the graph, it says this graph is representing the acceleration after the ball hits the wall. It's an elastic ball. When it hits the ball, it returns back, bounces back. So after this graph is showing after certain number of milliseconds, acceleration of the wall is presented in this graph. So I will certainly talk about the options, but what I'm saying is just by looking at the graph and based on whatever I've shared so far, what is your reading of, let's say at 10 seconds, after 15 milliseconds, what is your interpretation of this graph? Jenna, I'll come to the options bit, okay? I'm just trying to see how you're reading the graph. Is that okay?
Yep.
Okay.
In that case,
Uh-huh.
I think, well, the time 15, right?
Mhm.
I think since it hits 200, that could be the max.
Okay, that is max of what?
Like the acceleration.
Okay. Let's see what Praneeth says.
Yeah, I agree with what you said, and that was also when it hits the max speed.
It hits the maximum speed. Okay.
After it hits the wall.
Okay. How about you?
I agree with both of them. It at 15 milliseconds, it reaches its max at 200 for like the acceleration thing.
Okay. Okay, I'll give you guys a different perspective altogether. Yasmita, what do you think, Mita? Yasmita, Neil, Sarah, Vishal, Ananya, anybody. Think about it, okay? Don't think that okay the answer is already given. No, it's about how we all think individually. Because you will not have your friends in the classroom. Nobody will say the answer before you when you are giving the test. Samriddhi, what do you think? I'm not trying to put anybody on the spot. I'm just trying to get everybody's perspective. Because you'll be all alone solving this problem for yourself.
I'm not really sure. I'm still thinking.
Okay, Ria. What is that you guys are thinking? Okay, tell me that. Okay, I'm not trying to be a nagging teacher here. I'm just trying to read your mind, everybody's mind. Okay. Sarah, Neil, what are you guys thinking? Tell me better.
Okay, so I think that it first increases all the way up till the max point, and then it goes down.
Mm-hmm.
So like increases and decreases.
Okay.
Points the graph.
Okay. And I'll when I start speaking up, you guys will find a different perspective. That's why I'm first making you a thing. Okay, don't get biased with what I said. Okay. How about Vishal? What do you think? Vishal, Vishwa, what is your perspective?
Mine is the same. It's just like a parabola, which increases and decreases at one point.
Okay, yes, Vishwa, tell me.
Standard tracking is the same thing, increases at the same point.
Okay. Alright. So let me first do one thing. Let me first read the options for you guys, and again, it's not about volume. Let's say if we are able to solve only 2 problems today, that doesn't mean that we are not doing justice with what we are supposed to do. It's about making sure that we start aligning our thought process in a certain way so that regardless of number of problems we solve, we are better equipped for dealing with it. Okay, so let's see if somebody joined in between. Arush is here. Okay, Arush, are you with me, Uta, so far?
Yeah.
Okay. So let me read the options here. Okay. So now it's me solving it. Okay. Assuming I am giving the SAT exam and now my career is at stake. Okay. Whether I'm getting 200 in math or whether I'm getting 790 in math. Okay. That's where I'm in a tight spot right now. So when I look at this question, I have on this axis I have acceleration, meter per second. This is time. So just by reading this graph, what I know is when the time is 0, there is no acceleration. No acceleration. I did not say there is no speed. There might be speed, constant speed. It's going at a constant speed, let's say. When I'm saying acceleration is 0, acceleration and speed are two different things. Acceleration, velocity actually. You don't use term speed, you talk about velocity. So my velocity can be constant, let's say 50 meters per second. That would be a constant velocity. When I'm saying acceleration, that is when my velocity is increasing. When I'm saying deceleration, that is when my velocity is decreasing. If it's 0 and the start from 0, that's fine. If it's running at a certain speed or velocity, that will stay consistent as long as there is no acceleration or deceleration. Okay. Now, so at this point, whatever the velocity, there is no acceleration. After 5 seconds, probably it has got 50 meters per second acceleration. After 10 seconds, it has got a different acceleration, meaning it's accelerating, meaning somebody is pressing the gas pedal. Here there is no gas pedal, it's a ball that is thrown against the wall. At 15 seconds, this is the maximum acceleration. But I would not say this is the maximum speed. Because after 15 seconds also, at 20 seconds also, there is acceleration. Just that acceleration has started coming down. It's not reducing the speed. It is not increasing the speed at the same pace at which it was speeding here. So at this point, even still there is acceleration, which is let's say 150 or 170 meters per second square. That means velocity is still increasing. It's only the acceleration that is coming down. So Pranit, I'm basically arguing about the point that you made. You said that at this point there is maximum acceleration and there is maximum speed. I'm saying no, it's only maximum acceleration at this point. That's what the graph says. I still have acceleration. Even at this point I have acceleration. Meaning, whatever is the speed attained at this point, it is still increasing. Okay? So that's how we read it. Now, with that point being elaborated, let me read the 4 options we have. The option A says the elastic ball touches the wall for 30 milliseconds. The question was, what is the significance of the graph at t equal to 15 milliseconds? This is 15 milliseconds. It says the elastic ball touches the wall for 30 milliseconds. I don't know from where that option came, but I'm not able to relate to it. Okay, so I'll probably pause that. Let's move on to the second one. The elastic ball reaches its greatest horizontal speed at 15 milliseconds after the impact. After 15 milliseconds, it reaches the maximum acceleration, not the speed. Because my speed is still increasing, not at that same rate, but it is still increasing. So that second option is ruled out. Jenna, am I making sense, beta?
Yes.
Yeah? Yasmita, okay with whatever I'm saying? Somebody fine?
Yes, sir.
Okay. Sarah, Neil, everybody okay?
Yes, sir.
Okay. So next option is the elastic ball experiences the greatest horizontal acceleration 15 milliseconds after the impact. That is spot on. Because this axis is acceleration, this axis is time. It says this achieves the maximum acceleration after 15 seconds post the impact. That exactly narrates the same story based on the graph. And after that acceleration is coming down. It is still accelerating but little slowly. Yeah. Option 4 was, I did not write the option 4 completely, but I'll still try reading it. It says, the elastic ball experiences the lowest acceleration after this point. Not relevant for me. This is not it doesn't reach the lowest after this point. It is decreasing after that. But there is no straightforward correlation to what this option is. So there is only one option that is convincing enough, which says the elastic ball experiences the maximum acceleration 15 milliseconds after the impact. That's what I will agree to if I want to pass this exam based on this question. Do you guys agree to what I'm saying, or do you guys have a fear of me failing the exam? No? Ananya, okay? Ananya is convinced that the teacher will pass? Okay. Alright, let's move on. Let's go to the next question. So Vishal, Vasundhara, Arush, everybody clear about whatever I was saying, right? I mean, it makes sense to everybody? Okay. Now let's go to the next question. Okay, this question requires me to do a lot of drawing. That is where I start struggling or start shaking a bit, but we'll see. Okay, let me read the question first. The question says, a loan is paid back with increasing payments. A loan is paid back with increasing payments. First line, let's observe it for now. The balance of the loan upon purchase is $6,000. The balance of the loan upon purchase is $6,000. Okay? The balance reaches a maximum 2 years after the purchase. The balance upon purchase is 6,000. The balance reaches the maximum 2 years after the purchase. Okay? So when let's say you purchase today on 7th December 2025, as per this question it says balance which was 6,000 upon purchase reaches its maximum 2 years after. So basically on 7th of December 2027 the balance reaches its maximum. So balance is increasing. Maybe somebody is putting the interest, right? And then something is happening. Let's not worry about that. Okay, the balance reaches a maximum 2 years after the purchase and 5 years after purchase it reaches 0. So after 2 years it reaches maximum, and after 5 years, this is 2 years, and after 5 years it reaches 0. Meaning you got a loan of $6,000 and after 2 years it reaches its maximum. So what happens is when you take loan, whoever is the lender, they will add interest for you based on whatever is the repayment plan that you have chosen, and then they add that into your total amount. Okay, so they say, okay, fine, you are taking loan today. After 1 year, I will calculate the interest for that 1 year and say, okay, fine. On today's date, your total amount is 6,000 plus let's say 500 is the interest. So on today's date, your in the first month of this after the loan is disbursed, your balance is 6,000 plus 500, which is interest. So you took only 6,000, but your balance is 6,500. So that's why this one says that on the day of purchase, the loan is 6,000, but after 2 years, it reaches the maximum, and after 5 years, it reaches 0. Meaning there is an EMI plan that is configured for this plan. So after 2 years, it will show the maximum balance, but since the person who has taken the loan is paying the installment every month, after 5 years, the loan will be completely repaid. And that's the story. I mean, let's not worry about the loan right now, that parents are managing for you guys, but from a calculation standpoint. Okay. Now, it says if L is the balance of the loan in thousands of dollars and T is the time since the purchase in years, which of the following graph in the TL plane represents the payment plan? You heard this question enough from me? One last time. A loan is paid back with increasing payments. The balance of the loan upon purchase is $6,000. The balance reaches a maximum 2 years after the purchase and reaches 0 after 5 years. If L is the balance of the loan in thousands of dollars, L is the balance of loan, first letter of loan, and T is the time since the purchase in years, which of the following graph in the TL plane represents the payment plan? So now let's look at those options that we have. Option A is showing this 2, 4, 6, 8, and this is L, and this is T, and here 1, 2, 3, 4, 5, 6, 7. Okay. This one says starting from 5 goes to 6 and comes down to this. Okay. So starting from somewhere between 4 and 6. This is option A. Option B is this one. Starting from 6 goes to, let's say this is 2, 4, 6, 8. Starting from 6 goes somewhere and meets at 5. 1, 2, 3, 4, 5. Okay. This is T, this is L. Option C is this one. 2, 4, 6, 8. It is starting from 6, goes little bit above and meets here. This is 1, 2, 3, 4, 5. After 5 it meets somewhere. And option D is this one. 2, 4, 6. It starts from here, stays below 6 and meets at 1, 2, 3, 4, 5 and after 5. Yep, I see somebody join in between. Ritika, that
I just disconnected, so I just looked back.
no, Rita. I see one kid. Oh, Ritika is from 2 devices. That's why I see one child extra here. Alright. So, Jenna, I know you are super excited to answer this one. I will certainly let you answer that. But one last time, this is what the question says. This is the loan amount at the time of disbursement. It reaches its maximum value after 2 years, and after 5 years it becomes 0. And there are 4 graphs given to us. First one starts between 4 and 6, goes little above 6 and comes 1, 2, 3, 4. First one is it hitting at 5? First one is meeting at 5. Okay. So this is 2, 3, 4, 5. This is meeting at 5. 1, 2, 3, 4, 5. And then C is starting at 6, going beyond 5. And D is starting at between 4 and 6 and going beyond 5. Yes, Jenna, tell me what is the question or what is the answer?
The answer should be B.
Answer should be B. Okay. I will ask you why, but okay, Pranit is already agreeing to her. Vishal is also agreeing to her. How about Dutta? How do you think? What do you think?
I think it's B too.
You also think it's B. Okay. Ritika, Yasmita, Vivan, Biswa, what do you guys think? Samriddhi, Arush? Biswa is thinking? Okay. Thinking here is okay because there is nothing to lose here. My problem is here. When I'm thinking and scratching my head here, I end up losing, I keep on losing hair. Okay. So let's hear Jenna's point of view. Jasmita, you want to add something, beta? Jasmita, Ria, Ritika. I want each one of you to give your point of view because that makes our understanding right. How about Ananya? What do you think, beta? Which option seems more convincing?
A.
You think A? Okay. How about Samriddhi, Sarah, Neil?
I'm thinking either A or B. I'm not sure.
You think A or B? Okay. Sarah?
I'm still thinking.
Okay. Vishal? What is your point of view? And again, as I said, it's not about quantity, it's not about how many problems we are solving, it's about how many problems we are solving with that conviction. Because I'll be very honest with you guys, okay? I can take this class for next 5 weeks without teaching you guys anything. Because the concepts you guys already know. Now it has come to a point where how we are applying that concept, how we are kind of decoding what is there in the question and then coming to a problem. This is one of the highest scoring problem without even solving it. Okay. So let's hear what Jenna's thought process is. Jenna, so tell me why did you think that it could be B?
Okay, I think it's B because we start at $6,000, right? So that's like your initial value, and that's what graph B shows. And then
Right.
And that's again what gravity shows. Except 2, that's the max, right?
Right.
You go up. And then at 5 years, it says you reach like $0. And then as you can see from the graph again, that's what it says.
Yeah. Okay. So, Samriddhi, did Jenna convince you? Or did Jenna give you any clue with respect to how you can choose between 1 and 2, A and B?
Would you repeat that?
Yeah. Jenna. So, okay, let me do that for everybody, okay? So, I got Jenna's point of view and Jenna was spot on with her thing, okay? Now, I will do that in a layman's way, okay? Like I always do. That's what I'm qualified for, okay? Datta is thinking, where did I get trapped? Okay, the question says, the loan is paid back with increasing payments. Is paid back with increasing payments. The balance of the loan upon purchase is $6,000. The balance reaches a maximum 2 years after the purchase. So when you bought this was 6,000, this was the balance. But it reaches a maximum after 2 years of purchase, meaning this is certainly not the thing. Otherwise they will say, okay, the balance is only decreasing, right? So balance has increased from 6,000, that's what Jana was saying. And the next line says, and it reaches 0 after 5 years. So here, in next part of the question is, if L is the balance of the loan in thousands of dollars and T is the time since the purchase in years, which of the following graph in the TL plane represents the payment plan? Now, first thing is, starting balance is 6,000. Right after disbursement is 6,000. If I look at all these 4 options, which one has starting balance of 6,000? This one and this one. This one is between 4 and 6, this one is between 4 and 6. So these 2 options I'm not even wanting to waste my energy for. Ruled out. Method of elimination. Now you want to only focus on these 2 because one of it is right and your chances of being right is 50%. You knocked out these 2 unwanted ones. Now the next one says, the next part of the statement says, this is the opening balance after the purchase and after 2 years it is maximum. What that means is, it is going starting from 6,000, but this is not the maximum balance. It has increased from that. And in both the cases, if you see, after certain years, it is increasing. Both are increasing. But the only difference between this guy and this guy is, the last statement of the question says after 5 years, the balance is 0. Look at this guy. This guy comes here. Your loan amount, L, becomes 0 after 5 years. This guy is going beyond 5 years, meaning the loan is still carrying forward beyond 5 years. So this guy is not the right representation. So this is also ruled out. Does it make sense to everybody, including me? Does? Samriddhi, clear? Ananya, clear? Yasmita, Ritika, Neil, Sara, everybody?
Yes, sir.
Anything that is still not decoded and which is still making you think? Now, wonderful. So, I'll be very honest with you guys. Now, we will probably continue with this topic for maybe 1 more week at least. Okay? And we will solve more problems relating to this. But my guarantee to you all is I will not teach you guys any new concept. Because they are concepts that you have been knowing for some time. Be it all the graphs, be it the charts. These things you've been knowing since 7th, 8th grade. Right? And you have been learning different flavors of it. Then we have already learned about standard deviation. So now, no matter how many problems we solve, we are not going to learn any new concept at least in this topic. But then our focus will be more on the different approach, the different techniques, the methods that we learn and apply to get to the right answer. So basically, there will be a lot of word problems that will come across. So let's continue with that journey. Is this sounding okay so far? I'm not sure if I can say, is it fun? But is it okay? Yeah? Are you guys able to relate to it? And like I always keep bragging about, that reading the question makes the question less difficult. Okay, so that's the reason why whatever I keep recommending you guys with my run or RAN theory, I keep applying it. And just to showcase that, when you see the question in the first glance, it will not look very close to you, okay? When you read it once, twice, thrice, you will see that it starts coming closer to you. Much more easy to comprehend or relate. Am I making sense? Samriddhi, Yasmita, Neil, Ritika, yeah? And I hope you guys saw it happening when I'm reading the question a couple of times, yeah? Vivaan, do you agree with her? Probably you're the one who has heard this RAN theory more than many other kids in the class. Yeah? Obviously, Praneeth is one of the obvious victims. Okay, let's move on. I don't know if I enjoy sharing this with you guys, but I just want to make sure that we are practicing those concepts because that will certainly help us. Okay, let's go to the next problem. And this again is going to test my drawing skills. $20, $40, $60, $80, $100. This side we have $20, $40, $60, $80, $100. And we have certain points here. This point is 45, 10.1. This is the point. Okay, maybe not here. Let's say the point is here. And the second point is here. The coordinates are 55. Oops. I might have to use a different font. This is 45, 10.1. Then there is a point 55, comma 16 point, so it's here. This one is 55, comma 16.5. There is a third point which is 65, comma 26.9. Okay. There's a fourth point 75, comma 43.8. And there's a fifth point which is 85, comma 71.3. Okay. Now this was all to do with my drawing skills. This is T and this is B. Now let me read the question for you guys. I hope everybody can see the board, okay, right? I have put some certain points. This is T axis, this is B axis, and these are the points 55, 10.1, 55, 16.5, 65, 26.9, 75, 43.8, 85, 71.3. And these are the horizontal and vertical coordinates. Yeah. Now the question says, the graph in the TB plane shows the percent of normal brain activity. This shows the percent of normal brain activity. B, so this is B. This is the percent of normal brain activity that occurs when the human body is at a temperature T. So this is the percent of normal brain activity against the temperature of the body. Okay? In degree Fahrenheit. Which 10 degree Fahrenheit interval has the greatest average rate of change of percent of normal brain activity? Okay. So again, this graph is simple. You can, these points you can locate. Now they are trying to figure out a different information from this one. Okay. So let me read the question one more time, and then probably it might make a little more sense. The graph in the TB plane shows the percent of normal brain activity. This is the percent of normal brain activity. So this is normal brain activity. Let me say NBA. Yeah. Normal brain activity along this axis, and temperature, body temperature along this axis in degree Fahrenheit. Which 10 degree Fahrenheit interval has the greatest average rate of change of percent of normal brain activity? So based on these points that you see here, we have been asked to find out which 10 degree interval has the highest, greatest average rate of change of percent activity. So it's saying from here till here, or maybe from here you might want to see. Which 10 degree interval has the highest rate of change of the normal brain activity? And then we are given 4 options. Let me see if I can put the 4 options. First option is between 45 degree Fahrenheit and 55. Second option says 55 degree Fahrenheit and 65. So they have picked up the 10 degree range, okay? And we have to choose which one is correct. Third one is 65 and 75. Fourth one is 75 and 85. Is everybody clear about the question at least? Yeah? Can I assume that everybody has at least heard the question enough and is clear about what this question is asking? How to solve, what is the right answer, that part I will leave for you guys. But I'm assuming that you all heard the question right and you are ready to rock and roll. So I will give you guys a moment of silence, okay? I think Praneeth and Jana are already ready. Tell me what is the option. Don't give the answer or description of the answer, but tell me which option you guys are leaning towards. Praneeth. Sorry, Uda? Sure. Jana, are you giving the answer or you have the same point that you wanted to make?
I have an answer.
Okay, which answer you are leaning towards? B. Okay.
As a dog.
D as in dog. Okay. All right. So I will tell you guys an interesting story about dog. I had one friend of mine who had a much stronger accent than mine. So he had a boss named Doug, and one day he came to me and said, okay, I had a meeting with Doug. Which dog he met? I was scratching my head, eventually that led to some of the hair loss. I could not figure out. Then next day I realized that the CIO of the company's name was Doug. It was not Doug, it was Doug Macmillan. I'm talking about the CIO of Walmart. So he met with Doug Macmillan, whom he was calling his dog. Anyways, that was a bad joke. Let's move on. So Praneeth, for you, sorry for distracting you guys. This is the graph that you see. It says the graph in the TB plane shows the percent of normal brain activity. So along this vertical axis, you see percent of normal brain activity. Along this axis, you see the body temperature in Fahrenheit. The question says the graph in the TB plane shows the percent of normal brain activity, B, that occurs when the human body is at temperature T. So every point that you see, that is representing what is the brain activity at that temperature. So there are 5 points that you see here. So the question is, which 10 degree Fahrenheit interval has the greatest average rate of change of brain activity, or the percentage of brain activity? Is that clear, Praneeth, or you want to? I'm sorry? One more time. Say it one more time.
Can you say the final part one more time?
which 10 degree Fahrenheit interval, which 10 degree Fahrenheit interval has the greatest average rate of change of the percent of normal brain activity. Okay? So, Jenna told me the option is D as in dog, and I told a bad story. I will let everybody else tell me what their options are. What do you think?
I think it's D.
You also think it's D? Okay. Yeah, Praneeth. You also think it's D? Okay. Riya, Biswa, Sarah, Anaya, Nanya, tell you that, Nanya.
I was correct.
You also got D. Sarah, Neil, still working on it. Okay. Samriddhi, Vishal, Biswa, what do you think? Vivad? Okay. Yes, Samriddhi. Arush. My quiet guy. What's happening, beta? Tell me the option that you are thinking towards or leaning towards. Okay. I'll give you guys maybe 2 more minutes, okay? So that I can save some time for the next problem if I have one. And the reason why I pick up the questions for the class is because what happens most times, if I try cooking up some question by myself, I will either make it too difficult or make it too easy. And that might not align with the kind of questions that you guys will come across, right? So that's why I try picking up some standard questions from Khan Academy. That gives me a good view of, are you feeling cold? Okay. So Neil, Sarah, tell you some answer I want to hear before I start with my stunt. Ritika, how about you? What is the option that looks right here?
I'm still thinking, but I'm like, no.
Okay.
Yeah.
Go ahead. Don't. Yes, Rita? D? Okay. Okay. 1 more minute of silence from my side. Then I will start singing and dancing. So let's do one thing. All the kids who have given answer as D, I will say, Neil, do you want to describe it or why you think it's D?
I think D because it has like the highest slope or like highest out of all of them.
Highest slope. And what is this? What is this is asking for? Jenna, you said D. So what is this question asking for?
It's like asking for like the greatest rate of change.
Rate of change. Rate of change. That's the catch here, right? Datta, you agree? Praneeth, you agree? Here, for everybody, okay? This is saying what is the greatest rate of change in normal brain activity for the 10 degree range of Fahrenheit. If you look at this, the first coordinate is nothing but the x coordinate, right? The horizontal one, this is temperature. 45, 55, 65, 75, 85. So we don't have to do any calculation. Everything is given in the 10 degree range. So what it is saying is, when we went from 45 to 55, how much this one changed for this range. When we went from 55 to 65, how much did brain activity change for this 10 degree? So it's essentially talking about the slope of this line. Yeah? Or the rate of increase, rise over run, whatever way you relate it. Okay? So it is fairly straightforward stuff where you have to look at the slope of every segment between the 2 points and see, since every difference in the horizontal coordinate is only 10 degrees, that's what it's asking for. Yes, Neil.
The second part of the things are like very small, so I can't read them.
Okay. That's fine. I'll anyways do it better. So here, at least if you look at from the graph perspective also, look at here the slope. Slope is this way. It is going this way. It's going this way, and it's going this way. So here the slope is becoming more and more steep. You can optically also make a decision. Okay. So we'll look at it. So ultimately, all this range 45 to 55, 55 to 65, 65 to 75, 75 to 85. All these are the horizontal component are the same, 10 degrees. So rise over run is what we have to find out. In this case, my rise was how much? My run is the same, 10 degrees. So what is my rise here? It went from 10.1 to 16.5. So it changed by 6.4. In this case, how much it changed? It changed from 16.5 to 26.9. So 10.3, 4 actually. In this case, it changed from 26 to 43. So this is 17 minus 0.1. So 16.9. In this case, it changed from 43 to 71. So it's almost like 28, 27.5. So your run is the same in all the cases, but your rise is maximum for this range. So that's why 75 to 85, this is where your rate of change is the highest, which is option D. So all of you who gave me option D seems to be the answer or the option that I can agree for. And again, you can look at it optically, say okay, where the slope is more or less. You can just simply join the lines. When you have a graph in the examination hall, you can just visually join the dots and see where you are seeing highest slope. When your slope is higher, that means your rise over run is higher. That means the rate of increase is higher. Yeah? Does it make sense to everybody, or I have not been successful in convincing you guys?
It makes sense.
Make sense?
Yes, it makes sense.
Okay. So now, time for preaching. It's not time for preaching. I certainly don't want to pick up a new topic and get you guys rush for it, right? We hardly have 5 more minutes. But I have a request for you all, okay? Now what I want is you guys have to start playing with these things a little bit more. Data analytics, data analysis and problem solving is a topic that we'll probably use or invest at least 1 more week for, or maybe 2. That means 3 to 4 more classes. That is where we'll try practicing more and more problems to make ourselves very comfortable with these topics. But I also want you guys to do it a little more playfully, meaning try doing, be it IXL, be it Khan Academy unit test, be it any random question that you find on the internet. Try solving those and try bringing some of those problems to the class also. It is a good opportunity for you guys to check whether your teacher is even literate or not. Right? When you bring some problems to me and say, okay sir, can you help us solve this problem? Maybe I'm already preparing these questions and I'm memorizing them and I'm spitting it out in the class. Maybe, right? What I'm saying is you bring those problems. And jokes apart, the point is, more the problems we deal with, more we solve them, more varieties of or the flavors of problems we come across, we'll be better prepared as individuals. And if somebody finds a good problem that you have been able to solve or you have not been able to solve, put that in the WhatsApp group also, the group that we have, right? Say, okay, I found 2 interesting problems. When you start doing that, And when we start exchanging it among ourselves, trust me, it's a different learning experience altogether. Okay. I know kids here don't share much. I had a hard time convincing my elder daughter, say, okay, when you have friends, why are you not discussing the concept that you learn? And here I know kids don't do it as much as we used to do in our childhood days. But on a serious note, I would certainly love you guys to share those problems, exchange the problems, at least use that as an opportunity to evaluate whether your teacher is qualified to teach you or not. Okay? And I love problems. That's why I'm asking you guys to share those problems. If something is beyond my reach, I will figure out how do we solve it. What kind of approach we can build or derive using the whatever knowledge we have. Okay? But start exchanging those. I want this to be one of the most active group of kids where everybody is working on enhancing, enriching their knowledge base, having enough exposure to different types of problems, and then what is the harm if everybody becomes successful in this group? You guys are not in the same school anyway today, right? Alright? With that being said, I'll let you guys go. Enjoy the rest of the evening, and I'll upload the video of the class in a little bit, and then we will see where we go from there. Yeah? Alright, bye-bye, bye-bye. Okay. Who all do we have? Bye, beta.
Let me